in which heat was given by one hotter object and the same heat was taken by colder object. Okay. Now, we solved many questions also. Let me give you one question for quick practice. So, question is find everyone please note it while I am dictating because it is taking up time to start. Okay. In the meantime, you finish it. Find amount of heat released if 20 gram steam at 120. Find amount of heat released if 20 gram steam at 120 gets converted into, please note, find amount of heat released if 20 gram steam at 120 converted into is converted into 50 degrees Celsius of water. 50 degrees Celsius of water. So you need to tell me that how much heat will be released. Please tell quickly. Please tell quickly. Give answer. Aditya is saying minus 1200 calorie. Yash is saying 12 kilocalorie. Lisa is saying 1.2 kilocalorie. Sakshi is saying minus 12 kilocalorie. Aradhya, can you show me the working? Aradhya, show me the working. Aradhya. Yeah, share the rough page. Aradhya, share the rough page where you have calculated. Share it. I'm waiting, Aradhya. Still waiting. This is not today's question.
So no, sir. It is last. It is yesterday's question. I just replaced the values.
Where have you replaced? You said that you have solved it in rough. Show me that rough work. Aradhya,
So it did not.
let me tell you very clearly. You are trying to act smart, but you are not. And you are not studying at home. In class also, you are not studying. You are not solving questions. People have solved the question and you just copy pasted the same answer and you were thinking that okay, nobody will be able to find out. You have not done it. I know that. Yesterday also you answered without solving it. When I asked the working, you said I solved it mentally. Then I told you that I don't accept such answers. Today, so you change the word. I solved it in rough. Then I asked the working, you have no working. So even if you have solved in rough, show me that rough work. You don't have any rough work to show. You don't have any rough work to show. You are showing me yesterday's some other work and passing it as today's work. Everyone, please pay attention. So we have 120-degree steam. First of all, we need to convert it into 100-degree steam. Then we need to convert it into 100-degree water. And then we need to convert it into 50-degree water. That's what we need to do. So heat will be released here, Q1, Q2 and Q3. At these three places heat will be released. How much is Q1? Q1 is Ms delta T. M is how much? 20. S is half and delta T. Delta T is 20. So that comes out to be 200 calorie. So 200 calorie will be released when steam is converting from 120 to 100 degrees Celsius. Now Q2 will be ml. Q2 will be ml. How much is m? 20. How much is L? 540. So 20 into 540 is 10800 calorie. So this is Q2. Now Q3. Q3 is ms delta T. ms delta T. M is 20. S is 1. And delta T is 50. That becomes 1000 calorie. That becomes 1000 calorie. So total Q out will be Q1 plus Q2 plus Q3, and that comes out to be 2200 plus 10800 plus 1000. So this is 11 plus 1 will be 12,000 calorie or 12 kilocalorie. Okay, so this much amount of heat is released. That's why people are putting it with minus sign. That's why people are giving it with minus sign. Okay. Now I'm going to give you one type of questions which are very interesting. And what is that? Let me give it to you. I hope you all have noted this answer. I hope you all have noted this answer. Okay, everyone. And you need to be true and honest to yourself that you are studying or not studying. Don't just pass on someone else's answer as your answer without solving. I strictly don't like it. Okay. If you have done it, then say it that you have done. If you have not done it, then
Excuse me,
don't.
sir.
Yes.
How that Q2 part, can you explain me, sir?
Q2 is equal to ml. M is 50 and L is 540 because specific heat of steam is 540. Not specific heat, latent heat of vaporization is 540. Latent heat of vaporization is 540. We have talked about it yesterday.
Oh, yes, sir. Understood, sir. Thank you.
Okay. Next question. If 30 gram water at 30 degrees Celsius is mixed with 20 gram ice at minus 20 degrees Celsius, find final temperature and composition of mix. Now listen very carefully. When I am saying final temperature, that means you need to tell what will be the final temperature. And when I am asking composition, that means you need to tell how much water and how much ice. So these two things you need to tell. Okay. Please attempt. Zenobia is saying 17.5C. Okay. It is good that you have attempted, Zenobia. I cannot say whether it is right or not. We'll be talking about it when we are discussing it. Okay. In the meantime, you can recheck your answer. Other people give your answers. Aradhya, give your answer. Tanmay is saying minus 7.5. Okay. Sakshi is saying final temperature is 17.5 degrees Celsius. Okay. Two more answers and then I'll solve this. Two more answers. Right or wrong, immaterial. Rishikesh. 17. Okay, okay, okay. As so many of you are giving answer as 17.5, let us see whether that is correct or not. Everyone, pay attention. This question is example of on the rocks. We have water, we have ice, and we are mixing it. Very nice. Now pay attention. We have 30 gram water. 30 G water at 30 degrees Celsius. Now, if you pay attention between this 30 gram water at 30 degrees Celsius and 20 gram ice at minus 20, the temperature at which state change can occur is 0 degrees Celsius. Yes or no? That you can focus upon. Now listen carefully. When this 30 gram water, if we bring it to 0 degrees Celsius, okay, so water will be releasing heat. It will be Q out. It will be Q out. So how much will be Q out? So Q out will be M S delta T. M is 30, S is 1, and delta T is again 30. So the heat released is 30 into 30 is 900 calorie. So this is Q out. Okay, good. Now we have ice at minus 20. So ice minus 20 degrees Celsius. First of all, we need to bring it to ice at 0. Ice at 0 degrees Celsius. So we need to give energy. So Q in. Let me call it Q in 1. Okay. After that, if you want to melt this ice, then you have to give further heat. Okay. And that will be water. And that will be at 0 degrees Celsius. So that will be Q in 2. Okay. So how much is Q in 1? Q in 1 will be very easy, and that will be ms delta T. M is 20 because ice is 20 gram. S is half because specific heat of ice is half into delta T, which is 20. So that is 200 calorie. So 200 calorie of heat will be needed to shift the ice from minus 20 to 0. Okay. Now, if you want to melt the entire ice, listen very carefully. So Q in 2 will be ml. M is how much? 20. L is how much? 80, because we know that latent heat of fusion is 80 and there is no confusion. So 80 into 20 becomes 1600 calorie. Now, my dear friends, all of you, the total heat required Q in total is equal to Q in 1 plus Q in 2, and that is 1800 calorie. Okay. Listen very carefully. To get the entire ice first to 0 degrees Celsius and then to melt it, the total heat required is 1800 calorie. The total heat required is 1800 calorie. And how much heat do we have? We have only 900 calorie. Okay. So basically, let me tell you very clearly, we don't have 1800 calorie to get the entire ice melted. All right. So just by using common sense, we can say that entire ice will not be melted. Just by using common sense, we can say that entire ice will not be melted. And if entire ice is not melted, how come the temperature be 17.5 degrees Celsius? Temperature cannot be 17.5. Okay. So all those who are writing 17.5, let me tell you without even solving, that 17.5 degrees Celsius cannot be the answer. Right? Okay. Now let us see that how much. Let us see that how much will be the ice and how much will be the water. Okay. Pay attention fully. So try to understand when the water which was at 30 degree, okay, and it reached to 0 degree. So it released 900 calories. Okay. Now out of that 900, this part is extremely important. Listen very carefully. Out of that 900, 200 is spent just to bring ice from -20 to 0. Okay, good. So how much is left now further? We are left with 700 calorie extra. Okay, we are left with 700 calories extra. And now that 700 calorie of heat which is extra, what it will do? It will get some of ice melted. It will get some of ice melted because Q into whatever was sufficiently needed, we don't have that. What we need is 1600 calorie to melt entire ice, but we just have 700 calories. We just have 700 calorie instead of 1600. So entire ice will not be melted, my dear friends. The only part which will be melted, let us see how much will be that. And that will be 700 is equal to m into 80. Because 80 is the amount of heat needed to melt 1 gram of ice. So if total m gram is melted, then 700 is equal to m80. And that gives us m is equal to 700 upon 80. 700 upon 80, and that will be 70 by 8, that means 35 by 4. Okay, and that means 8.75 grams. So this much gram of ice will be melted. This much gram of ice will be melted. So total how much ice we had? We had 20 gram ice. How much is melted? 8.75. Okay.
Excuse
So
me,
I
sir.
just wait. Ice left will be how much? 20 minus 8.75. So that will be 20 minus 8.75 is how much? Can someone tell me quickly? 11.25. So this is ice. So water will be how much? 8.75 plus 30. So hence water is equal to 30 plus 8.75. So that will be 38.75 gram. Yes, somebody was saying something. Please tell. Please
So
tell.
how did you get to know that we only have 700 calories?
Because we have simple mathematics. Total needed is how much? 900 calories, right? The total heat which we had was 900 calories. Yes or no? Say yes, sir. Hello.
Yes, sir.
Okay. So the heat which was released due to lowering temperature of water, it is ms delta T, and out of that we got 900 calories. Now this 900 calorie which was extra is inside the vessel, correct? And this 900 calorie is going to first of all increase the temperature of ice, and secondly it is going to melt the ice, right? So to increase the temperature, how much will be spent? It is simple hisab kitab, money matters. So 200 calories are spent just to bring ice from -20 to 0 degrees Celsius. So now how much is left with us? You tell me.
700, sir. Got
Yeah,
it.
so that 700 is being used for melting of ice. Okay, hisab. This is nothing but hisab. Okay. If you are good at hisab, you are good at physics. As simple as that. All right. Noted, everyone? If you have any question to ask, do not hesitate and ask now. If you have any question to ask, do not hesitate. There is no place for hesitation in my class. And if you don't have any question, then I'm going to give you another question now. Noted, everyone? All of you understood those who answered earlier: Zenobia, Tanmay, Sakshi, Rishikesh, Lisa, Spruha, Divyanka, Sanika, Rishikesh, Jeremiah, Hiram, Ibial. Okay, so Tanmay is asking a question. Tanmay is saying, so sir, the temperature of composition will be 0 degrees Celsius. Yes, Tanmay. Why? Because when both states are there, two states, you know, people make movies and write novels on that. So those two states, when they are present, the temperature has to be 0. Temperature has to be 0. Why? Because ice and water are can coexist only at 0 degrees Celsius. Ice and water can coexist only at 0. Okay, Hiram? Hiram?
Yes, sir.
Understood? Good, good. So that's why, as the ice is also there, water is also there, I did not even talk about final temperature. Okay? Good, good. Let us move further. So this was a good question. And let me tell you how you were getting wrong answer. You must have applied that formula: heat given by hotter object is equal to heat taken by colder object, right? But what you forgot was that state changes involved in this. State changes involved in this. You forgot that you need to change the vehicle from airport. You need to go to airport and then you need to take the plane. Okay? What you did was you were going through a car and you took it as a plane. Okay, that's why you got the wrong answer. Okay, Hiram is saying, sir, could you please explain how you got 700 again? Hiram, pay attention. We had 30 gram water at 30 degrees Celsius. Okay, this is quite obvious that the 30 gram water which is at 30 degrees Celsius, it will be lowering its temperature in this question because ice is there. So what we did, we lowered the temperature to 0 degree. We lowered its temperature to 0 degree just by using common sense. Now when it is lowering its temperature to 0 degree, how much heat is released? It is 900 calories. It is 900 calorie because see, we are not getting any heat from outside. We are not getting any heat from outside. Whatever is inside the vessel, that is going to help us. So someone is going to give the heat, and that heat is given by the water which is at 30 degrees Celsius. Okay. Suppose, let me put it in different words. Suppose we have 5 people. Okay, just 5 people. And out of those 5 people, I have money. Okay, someone was supposed to have the money, and I am assuming that I have the money. And rest 4 people, they are in below poverty line condition. Okay, they need money to eat food also, they need money to raise their level of living also. So what I did, as I have the money, I gave some of the money. So first of all, what they are going to do, they are going to eat food, because that is the most necessary thing. Okay, once they have eaten the food, then they are going to raise their poverty level. Okay, so similarly, this 900 calorie, when it is given, we had two steps. First was to raise the level of temperature of ice from -20 to 0, because if you are melting the ice, then that is second step. But melting can occur only at constant temperature, which is 0 degree Celsius, right? So to get the ice melted, at least you need to bring it to 0 degree Celsius. So how much is the heat spent in that process? So heat spent in the process is 200 calories. Q is equal to ms delta T. Now we started with 900. We had money of 900 calorie. 200 is spent for bringing the ice to 0 degree Celsius, where it can get melted. So now with how much we are left? We are left only with 700, because 900 minus 200 is equal to 700. Understood, Hiram? Hiram, understood now?
Yes, sir, understood.
Good. Next question on your computer screen for, you can decide the amount. Question. 40 gram water at 40 degrees Celsius is mixed with 30 gram ice at -30 degrees Celsius. Find final temperature, and composition of mix. Just to remind you, this topic of calorimetry is very important from KVPY point of view. They ask questions from this topic many times. Okay, just informing you. Just to give you practice, I have kept values in such a way that the solution will be almost similar to previous question. Okay, please get it solved. Hmm. Okay, everyone, please pay attention. So in this question, In this question, we have 40 gram of water at 40 degrees Celsius. So let us first convert that into 40 gram water, 40 degrees Celsius. We are bringing it to 0 degrees Celsius. Okay, 0 degrees Celsius. So Q will be released. So that will be Q out. And that will be the money for us to spend. That will be the money for us to spend. So Q will be MS delta T. Soham, please keep your mic muted. Soham, whatever you are watching, please watch it after muting your mic. M is 40, S is 1, and delta T is 40. That comes out to be 1600 calorie. That comes out to be. Soham is not even bothered about what I'm saying. Okay. So Q out comes out to be 1600 calorie. Now, the next thing which we need to do is we have ice at minus 30. Okay. At minus 30. We need to bring it to first ice at 0 degree and then we need to melt it. So water. This time it will be water. Okay. So this will be Q in 1 and this will be, let me use arrows in opposite sense because heat is going inside. So arrow should be 1 and this will be Q in 2. Okay. So this will be 0 degrees Celsius water. Okay. So how much is Q in 1? So Q in 1 is MS delta T. M is 30, S is half, and this is 30. So that comes out to be 450 calories. 900 by 2 is 450. 900 by 2 is 450. Okay. Q in 2 we are calculating, but you can work without it also. Q in 2. Q in 2 will be ML. M is 30, L is 80. So that will be 2400 calorie. So total how much do we need to get the entire ice melted? We need 2400 plus 450. But how much do we have? We have only 1600 calories. Okay. So delta Q is 1600 minus 450. 1600 minus 450 and that comes out to be 1150 and this 1150 will be used to melt the ice. So M into L. L is 80. So M comes out to be 1150 upon 80. My dear friends, 115 by 8. 115 divided by 8 and that will be 14.375 grams. So this much amount of ice will be melted. This much amount of ice will be melted. So how much ice is left? Okay. How much ice is left? That will be 30 minus this. So ice left will be 30 minus 14.625. No, not 14, 15. 14.375 basically. 14.375, and that comes out to be 15.625. So this much gram of ice is left. So water will be how much? 40 was already there, plus due to melting of ice, and how much ice is melted? 14.375. So 44.375 gram. Ice is also there, water is also there, so temperature of mix will be 0. Temperature of mix will be 0. This will be the answer. Okay. Just a second. 40 plus 14 will be 54. 40 plus 14 will be 54. Okay. So how many of you are getting the same answer? Tell me. Tell me today. Tell me today. Good. 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 Very good. Very good. Sanika is saying yes, sir. Got it. Those who got the correct answer, please write your name in the chat box or mention. Okay. Next question. Next question. Okay. Okay. Next question. If 50 gram water at 50 degrees Celsius is mixed with 20 gram ice, okay, at minus 20 degrees Celsius. Find final temperature, find final temperature and composition of mix. Good, good everyone, good, good. Hmm. Three persons are saying that the answer is this. Four persons now. Okay. And this time people are saying, sir, there is no ice. Okay. Pay attention, everyone. Pay attention. So we have 50 gram of water at 50 degrees Celsius. We have 50 gram water at 50 degrees Celsius. Okay. So we are converting it into 0 degrees Celsius, and this will be water only. So Q will be out. Q will be out. So Q out will be m s delta T. M s delta T. M is 50. S is 1. Delta T is 50. And that comes out to be 2500 calorie. That comes out to be 2500 calories. All right. All right. Now you have ice minus 20 degrees Celsius. Ice. We need to get it to 0 degrees Celsius. Ice. We need to get it to water at 0 degrees Celsius. So at these two places we need to give Q in 1 and Q into Q in 1 and Q in 2. So Q in 1 is how much? M has delta T. M is 20, S is half, delta T is 20. That is 200 calories. So out of whatever we had, 200 calories is spent in bringing that ice from minus to 0. Now let us melt it. So Q into will be YL. Yum is 20, L is 80. 20 into 80 will be 1600 calorie. Listen very carefully. Delta Q. This will be 2500 minus 200 plus 1600. So we are left with, still we are left with 700 calorie. Still we are left with 700 calorie. And in the mixture, total mass is total mass of water. Okay. So that is 50 plus 20 is equal to 70 gram. And as of now, the temperature is 0. So the question got converted into, if 70 gram water is at 0 degree Celsius and you are giving it 700 calories, what will be the final temperature? So 700 will be M, which is 70, into S, which is 1, into delta T. So, bhaiyo bahno, delta T comes out to be 700 by 70, and that comes out to be 10 degrees Celsius. Okay. So the answer will be 10 degrees Celsius. Zenobia, we added 1600 also because that is also spent. That is also spent. Okay. 200 calories is also spent. 1600 is also spent. So total how much we have spent is 1800. Okay. Understood? Yeah. See, from your place to the mall, you spent, let's say, 500 rupees. Now in mall also you spend 100 rupees in the parking. So total how much you have spent in the traveling? 500 from your place to the mall plus 100 rupees of parking, because that will also be considered as transportation cost. If you would not have taken your vehicle, you could have saved on parking also. So 500 plus 100 becomes 600. Same way, the temperature first you shifted from minus 20 to 0, and then you melted also. That is also a cost. Okay. So melting cost is 1600 and the cost of raising the temperature is 200. So total cost is 1800. Okay. Because the language was different, Zenobia, requirement was different. Okay. We did not reach to that level in previous question. Not entire ice was melted in previous questions. In previous questions, entire ice was not melted. Here entire ice is melted and now we need to raise the temperature after that because we have extra heat. We have extra heat. So now in this question, let me tell you, you have been able to reach to the mall. You have been able to put your vehicle in the parking. Now you have extra money. So now you can reach up to any shop and do some purchasing or some shopping. In previous questions, you are not been able to park your vehicle completely in the mall because you were left with no money. Okay. In previous two questions, you were not able to pay the parking fees because you are not left with the sufficient money. Okay. You were supposed to pay 100 rupees for the parking, but you were left with 20, 30 or 40 rupees in previous questions. Good. Next question.
So please scroll up.
Okay.
As in a little bit more.
Okay. Where were you?
Got disconnected.
Okay, okay, no problem. All right, done. Good. Good. Question. 50-gram ice at minus 50 degrees Celsius is mixed with 20-gram steam at 120 degrees Celsius. Nice question. Find final temperature and composition of mix. See, many people do on the rocks. That is very obvious for the people. But passing steam on ice, who do that? Okay, who does that? So let us do this time and get the answer. Please solve. I'm waiting for your answers. Yash is saying, what is the temperature, Yash? Yash, what is the temperature? Yes. Yes. What is the temperature? Okay, 133.2 you are getting. Very nice. Let me tell you one very interesting thing. Very interesting thing. There was a person who started from Panjim. Okay. And another person started from Margao. They were supposed to meet somewhere in between. And you know what? Their meeting happened at Mumbai. Their meeting happened at Mumbai, according to you. How, sir? Temperature of one object is 120. Temperature of another object is -50. Right? And when you have mixed the two, temperature became 133. Correct? Temperature became 133. So meeting happened at Mumbai. Very nice. Very nice. Such things happen when you don't use common sense. Okay. Now let me talk to you, Mr. Tanmay. Let me talk to you. Now your turn. You are saying that the answer is 70 gram of water and temperature is 110.71. That's very nice. Excellent. But you forgot that above 100 degree water does not exist. If at all is existing above 100 degree, then it must be steam. Then it must be steam. If you are saying that water is there above 100, then you are wrong. You cannot be correct. Understood? Above 100 degree, water cannot exist. If you want to increase the temperature above 100, then steam must be present rather than water. You also made the same mistake, yes. You had 70 gram of water at 133. Okay. No, don't be sorry. Keep all these points in your mind. Okay. So that you don't make the same mistake again. So now, as enough time has been given to all of you and I did not get any credible answer. So let us move further and solve this. Okay. The problem which you might have faced in this question, that there are two airports. One airport is at 0 degrees Celsius where state change is occurring, and the another state or airport is 100 degrees Celsius where state change is occurring. So which airport to take? Which airport to take? Correct? Now, as your answers are coming or talking about steam or 110 degrees Celsius, so I think you must have realized that the airport which we should pick or choose is 100 degree Celsius. So let us first bring everything at 100 degrees Celsius of water. We are bringing everything at 100 degrees Celsius of water and see that what is the scenario. Do we have extra heat or less heat or what? Okay. So bringing everything at 100 degrees Celsius of water. Okay. So let us see what we need to spend. So let's first talk about steam. So you have steam 120 first, 120. So first you are converting it into steam at 100 degrees Celsius. Then you are converting into water at 100 degrees Celsius. Heat will be released. Q out 1, Q out 2. So how much is Q out 1? So Q out 1 is ms delta T. M is 20, S is half, and delta T is 20. So 20 into this, that comes out to be 200 calorie. Now Q out 2, and that will be ml. M is 20 and L is 540. So that comes out to be 108 not. So total Q released, total Q out. So Q out total is equal to 200 plus 10800, and that is 11,000 calorie. So total heat released, my dear friends, is 11,000 calories. Okay, we have taken a note of that. This is our earning in terms of heat. Now let us talk about expenditure of heat. Okay. So I hope you have noted this much. So the second thing which we need to do is, we had ice. Ice is 50 gram ice at -50, I guess. Yeah. So let us convert that also into water at 100. So ice -50 degrees Celsius. So you are bringing it to 0 degrees Celsius ice. Then you are melting it 0 degrees Celsius of water, and then you are getting it to 100 degrees Celsius of water. Okay. So in all these processes, we have to give heat. Q in 1, Q in 2, Q in 3. Okay. So Q in 1 is equal to ms delta T. M is 50, S is half, and delta T is 50. So that comes out to be 2500 calorie. So this is in the first round. Now in second step, Q into, and that will be ML. Yum is 50, L is 80, because latent heat of fusion of ice is 80. So this becomes 8 into 5, 40 plus 00. So 4000 calories is spent here. I am not picking final. So Q in 3 will be again M as delta T. Yes, you are right, Daryl. It will be 2500 by 2, and that will be 1250 calorie. Thank you so much, Daryl. Q in 3 will be M as delta T, and that will be M is 50, S is 1, and delta T is 100. So that will be 5000 calorie. That will be 5000 calorie. So how much is Q in total? Q in total. That will be Q in 1 plus Q in 2 plus Q in 3. And that is 1250 plus 4000 plus 5000. And that will be 549 plus 110, 10250 calories. Okay. Okay. So delta Q will be Q out minus Q in, and that is 11,000 minus 10250, and that will be 750 calorie. So listen very carefully, everyone. After bringing everything at 100 degrees Celsius of water, we still have excess of heat. So when we have excess of heat, the question got converted into 50 plus, how much was that? 20. 70 gram of water. 70 gram of water at 100 degrees Celsius is present, and we are passing 750 calorie of heat through it. How much water will get converted into steam? That's very simple. So Q is equal to ml. So delta Q is 750 is equal to M is to be calculated. L is 540. So M comes out to be 750 upon 540, and that is 75 by 54. 75 by 54. That comes out to be 1.388. I'm writing it as 1.39 gram. Okay. So this comes out to be 1.39 gram. So this much amount of steam will be there. Rest everything will be water, and temperature will be 100 degree Celsius. And temperature will be 100 degree Celsius. Okay. Okay, everyone understood this? Yes, he's saying, sir, can we also bring everything at 0 degrees Celsius and solve? Yes, you can solve by any way, but you cannot change the answer. The answer will come as per calculations and as per science. Answers will come as per science. So answer comes out to be 1.39 grams of steam. So ultimately you have to take it back to 100 degrees Celsius because steam has to be there. So if you want to do it that way, you can do, You can do, but after that, what you need to do is you need to bring everything back to 100 degrees Celsius, and then you need to get some steam. And how much steam? 1.39 grams. Understood, everyone? Please tell me. Please tell. Have you understood, everyone? Okay. Any question related to this? This was a good question. This was a good question. Okay, everyone? Okay. Okay. So that is enough for today. We'll study further in the next class. Thank you so much. Keep studying, keep solving questions.